Hello, and welcome to Advancements in Analysis of Human Remains, presented by Forensic and sponsored by Thermo Fisher Scientific. This is the fifth webinar in the six-part Future Trends in Forensic DNA Technology series. My name is Michelle Taylor, the Editor-in-Chief of Forensic, and I will be your moderator throughout. For today's webinar, you can earn 1 hour of continuing education credit. Following the conclusion of the webinar, you will receive an email with information on how to obtain CE credit documentation. We have a great lineup scheduled to present to you today, but before we begin, I'd like to take just a moment to cover a few logistics. At the end of the presentations, we will hold a question and answer session. To ask a question, click on the Ask a Question tab in the upper right corner of your screen. Please also note that the right side of the screen features an overview of today's webinar, as well as more information about your speakers. If you have a technical question during today's event, click on the Test Your Connection button on the bottom of your screen. From there, you can access additional webinar support. We also invite you to use the social media widgets beneath the webinar to share with your friends and colleagues. Today, you will hear from Sheree Hughes, who is an Associate Professor of Forensic Science at Sam Houston State University. Sheree completed a PhD in Health Sciences and Forensic Genetics at Bond University on the Gold Coast in Australia, investigating forensic DNA typing methods for highly degraded samples, such as those recovered from mass disasters, missing persons, and historical cases, in conjunction with DNA repair techniques and phenotypic SNP analysis. In 2015, she was appointed by the governor of Texas to the Texas Forensic Science Commission. You will also be hearing from Rachel Oefelein, Senior DNA Analyst and Director of Research and Innovation at DNA Labs International. Rachel is currently a PhD candidate with Griffith University in Australia, having received her Master of Science in Forensic Science and BS in Criminal Justice with a Forensic Science minor. Prior to DNA Labs International, Rachel worked at the Armed Forces DNA Identification Laboratory. Rachel has testified in 10 Florida counties, 3 states, and 4 countries as an expert witness for both the prosecution and the defense in misdemeanor and felony trials. Thank you for attending the 5th session in the 6-part Future Trends in Forensic DNA webinar series. After the webinar, please be sure to check your email for more information on CE credit documentation. We look forward to seeing you on October 15th for the 6th and final part, DNA Hit of the Year, DNA Database Programs Help Solve More Crime. Without further ado, I'm going to hand it off to Sheree to get us started.
Thank you, Michelle, and thank you, Thermo Fisher, for inviting me to speak today. So I've been asked just to share some of the work that we've done in our labs around processing bone samples and how we've integrated Thermo Fisher's traditional STL workflow and their DNA extraction chemistries with a little bit of a twist for multiple applications in our lab with some success. So the majority of the work that I'm presenting today was performed by one of my former PhD students, Michelle, and my recently graduated honours student, Madeline. So the stock standard disclaimer, of course, and let's get straight into it. So we all know that there are multiple challenges with skeletal samples. Sample processing can be extremely long, lengthy, and laborious and can require some specialized equipment and training, and often it will consume or completely consume a precious sample. We have a lot of PCR inhibition that we need to consider, and with the DNA extraction method obviously needs to be effective of removing all of those inhibitory agents. The DNA we yield from a lot of skeletal samples is going to be in very low amounts and can often be highly degraded or even damaged, and this can lead to difficulties and challenges for downstream STR typing. We also need to bear in mind the increased risk of contamination in these very low level samples as well. But also one of the steps in the sample processing of bone, where we powder into a very fine powder, can increase the risk of that contamination as well. So of course the traditional STL workflow in the laboratory should look familiar to you all, and the work I'm presenting is using all of these Thermo Fisher kits and chemistries on these instruments, all the way from extraction through to separation detection on the 3500. So the general sample prep of bone samples essentially always starts with a sanding. So we would sand off usually the top millimeter or so of the bone to remove a lot of those external contaminants. Then we would go through a series of chipping into smaller fragments, wash series of bleach ethanol water, and then crushing that bone into a very fine powder, either with a freezer mill, as you see here, or a blender cup, or with a drill. So once we have that powder, we then need to extract the DNA from that powder. And one of the industry standard methods now is what we would call a complete or total demineralization protocol from bone powder, which is pretty much used in the majority of bone labs around the world now. In terms of, it was originally described by Laurel et al. And has been further refined by that same group and described and used by many, many other researchers. And essentially it's relying on an increased concentration of EDTA to maximize that decalcification and mineralization and completely demineralize that powder. Now, the PrepFiler BTA kit was released by Thermo Fisher, and it was developed with a very aggressive lysis buffer as well for bone and tissue samples, bone and teeth. And again, we wanted to incorporate this in our lab for various projects. And again, both of these methods are relying on extracting from bone powder. However, there are times where we would like not to have to powder. So labs may not have the equipment to powder bone to crush bone into a fine powder. So this is also a really interesting sort of method or approach for precious samples that you may not want to destroy. So maybe some museum or ancient remains you don't want to be totally destroyed. So maybe this is something that could be used to extract DNA, still leach DNA out of those samples while maintaining the integrity of the sample itself. This may also reduce the potential for contamination if you're not powdering and creating all those aerosols of bone powder. And also, interestingly, you can then go back and re-extract from that same sample a second time. And so a few people have looked at different approaches for this with bone and teeth, as you can see here. And then a little while ago, the T-Bone X kit was developed specifically for this reason, to be able to extract DNA from whole bone tissues without having to powder. And so it's an initial digestion step that you would then pair with another DNA purification step. In our case, we wanted to look at the combination of the T-Bone kit with the PrepFiler BTA kit. So the first project I want to talk about is exactly that. It's looking at the results for STR typing with powder versus chips, using powder versus just chips, so being able to avoid that powdering step. Look at BTA, PrepFiler BTA alone or with the T-bone buffer. Is there going to be an accumulative improvement of the T-bone kit? And then look at manual versus an automated approach. So we collected 6 bones from skeletonized remains out at staffs at Sam Houston State Uni, and we subjected them to those DNA extraction methods. So the total demineralization protocol from powder, PrepFiler BTA from powder, and then PrepFiler BTA combined with the T-bone buffer from the chip. Right, so and then combination of manual versus automated downstream purification on the Automate Express. So looking at our control method, we would crush the bone powder and go through your demineralization protocol manually for around about 30 hours or so that would take. Then using the PrepFiler BTA kit, again from bone powder through down to cell lysis with the BTA kit. But now looking at introducing the T-bone kit prior to PrepFiler, we of course are able to avoid the crushing and the processing of the tissue into a powder. Added then to the demineralization and digestion with the T-bone kit, and then both of these then are subjected to the PrepFiler BTA kit, either manually or automated is what we are looking at for our comparisons. So as expected, we did see a significant decrease in the amount of DNA that we recovered when that process was automated. And this wasn't unexpected. Bone labs pretty much would traditionally use a manual extraction procedure for this very reason, for the fear of losing whatever little DNA we've got. We essentially don't want to be losing due to robotics. However, when we looked at the STR success from those DNA extracts, we found that there was no significant difference at all between the STR success based on those methods. So the prep filer BTA was the quickest overall. Even though we had to powder, it was still the quickest. We could avoid the overnight incubation. But more importantly, the T-Bone X kit really didn't have any additional benefit over BTA alone. However, the BTA prep filer kit was still dependent on powdering the bone. So we wanted to look at, well, if the BTA buffer is really good at digesting from the bone powder, is it aggressive enough and effective enough on bone chips without having to powder it? And then if so, will this number and the size and the number of chips that we use for digestion, is that going to make a difference? And if we increase the incubation of the initial incubation step because of the chips versus the powder, would that improve our results? So we took a bone from a badly burnt body, sanded and processed it down, and then we looked at a different combination of different size chips and the quantity of chips, and then that incubation time, and coupled that with our prep filer BTA extraction. So we had our bone powder and our bone chips, we mirrored the amount. So we had 50 milligrams of bone powder, and we also had 150 milligrams of bone powder. We also had 50 milligram bone chips, so 1 for the 50 milligram, 3 to make up the 150 milligrams, and then 1 large 150 milligram powder chip. And then we looked at increasing the incubation from the recommended 2-hour protocol through to a doubling of 4 through to an overnight incubation. And what we found is that there was no significant difference in DNA yield or STR success based on any difference in the incubation time or the combination of chip number and or size. The only difference we did see, as what may be expected, in the DNA concentration, when we got our DNA yield, we recovered less DNA from 50 milligrams than we did 150, but there was no difference in whether it was a powder or chip. So none of the alternate variables that we looked at actually generated any significantly better results than the initial manufacturer's existing protocol of 50 milligrams of bone tissue with a 2-hour incubation. But now we were able to demonstrate that we did not need to powder that 50 milligram bone. We can extract from the chip itself. So then we were asked, well, what else can we do with this protocol? Labs may, if they don't have the equipment to powder their bone, could they use this as an initial very quick rapid screening tool to decide, well, what are the likelihood of STR success from these bones that we may have? Or really, do we need to send them off to another lab to do some MITO or MPS or some other type of specialized preparation? And so we wanted to look at, can we use this bone chip on a very quick automated process on the Automate? And then it was, well, what other skeletal elements may this work for? Not just your traditional bony elements and your long bones, but any other parts of the body. So we wanted to look at that as well across different environmental insults. So again, we started off with our controls. So we have our powdered controls, our 50 milligram samples, one that were processed either with our total demin method or our prep filer BTA method manually. Then we wanted to look at, okay, our screening method is using a very quick 50 milligram chip, no powdering, straight onto the Automate Express using the prep filer express chemistry. And then processed the same for our quant and STR typing, of course. So what we found using this automated screening method with the chip is that we didn't find any significant difference in DNA yield. As you can see, there's a trend for less from the chips compared to our control methods. But when we looked at the STR success, we did see a slight variation in our results. So as you can see, powder versus the bone chip, we did have more samples that were generating more complete STR profiles using the full bone powdering and manual method. However, when we wanted to look at what's the effectiveness of a very quick screening method using a chip, we found that just under a half of the samples we tested were generating more than 95% complete profiles from the chip alone on the Automate Express, and just over half, so 13 out of the 20 were generating more than 75% complete STR profiles. So we thought this method, the advantage of being able to avoid the powdering, was providing a very quick and easy screening tool, essentially. Then an interesting observation we had was looking at these traditional versus non-traditional skeletal elements for extraction. So our traditional elements are your long bones, your compact bones, the shaft of your long bones, and that are weight bearing. So traditionally your femur and your tibia, but also your humerus. But we also wanted to look at your non-traditional bones. So your hand and feet phalanges, your fingers and toes, your carpals and metatarsals, broken tooth fragments, your vertebra, rib ends, other bones within the body that wouldn't traditionally be your first choice. And what we found is that non-traditional elements appeared to be yielding slightly more DNA and slightly less degraded DNA, as you can see from the slightly lower DI and quant values. However, these were not statistically significant in any way. But what was significant was an increase in our STR profile completeness. So the number of reportable alleles, we actually got more complete profiles from these non-traditional elements. So this was great because it means we can survey from much wider selection of skeletal remains when we have them in a case. And this is not a surprise. This has been shown by multiple researchers and reports that other non-traditional skeletal elements can be used very successfully for DNA typing. This is more information on everything I've presented thus far we've also published, so feel free to read that if you want after more information. But then we wanted to look at something slightly different. So we were asked to look at using our large range of environmentally challenged skeletal remains using with global filer at the time. It was unknown on what the effect of increasing the cycle number from the recommended 29 cycles of global filer with some compromised bone samples. What was the effect? So we got asked to look at that, and we looked at several increases. Because, of course, it's increasing our PCR cycle number is your most common technique used for trying to increase your allele recovery from low template remains. So we we took about 12 bone and tooth samples from cadavers that had been subjected to a lot of different environmental insults, such as burial, burning, embalming, decomp, etc. We processed these in our stock standard method. We powdered these bones, and then we performed extraction in duplicate. So what we found, not surprisingly, is that overall, as peak heights did increase as the cycle numbers increased, of course, and also the number of reportable alleles increased with additional cycles. But this obviously was the greatest increase was observed under 120 or so picograms, which we would expect. And on the flip side, though, as expected, was that we saw an also increase in the number of artifacts that we saw as we increased our cycle number and the amount of DNA amplified increased. So we were able to sort of confirm that trend and have a look at the variation from 29 to 32 cycles. We would see an increase. We saw an increase in stutter exaggerated stutter. And we also saw an increase in drop-in as we increase the cycle number, pull-up, of course, and we did see off-ladder events as well, increasing the more we would increase our cycles. So here's an example of a, say, 60 picogram sample with 29 cycles, recovering around about just under 35% of their alleles with no artifacts. Increased to 30 cycles, we were able then to recover another 20% or so without seeing any more unwanted artifacts. Up to 31 cycles, we were then able to recover 70, just over 70% of our profile. But we now start to see artifacts, and then of course increases those artifacts, but we're not seeing any increase or much improvement at all in our number of alleles recovered. So this helped. This work helped Thermo Fisher then tweak some of their protocols and also an application note on these, and we also published these results as well. So of course our HID tools could be used for multiple applications. Everything from our routine forensic casework and crime scene investigations through to missing persons cases and mass disasters, solving historical cases, and something a little bit different is using HID for improving the traceability and tracking of specimens within an anatomical collection. So usually what happens in a facility, a body donor program, is when they are received, the bodies are assigned a unique identifier and tagged upon arrival. Then those bodies goes through the embalming process, and then when they are then housed and used for research and teaching, those bodies are then dissected and will be separated into various areas and containers. So of course those tags then are, the isolated organs are tagged. And these, this identifying number obviously is then associated with that original donor within a registry. But does it go wrong? Well, every now and then it has. And of course, this is an extremely serious issue. We want to make sure that bodies and body parts are correctly assigned to their donor so that they can be cremated and returned, obviously, to families as required. And of course, when this has happened in the past, very isolated incidences, DNA typing has been relied upon to then try and reassociate those remains to the known donor. But as far as I'm aware, there is no anatomical or body donor program in the world yet that routinely has established and uses a DNA database and tracking system to establish the identification of all of their donors and their specimens within the collection. So this, of course, could be a way of improving the traceability of these organs within a facility and increase and really boost their quality assurance programs. So how this project came about was the university I was recently at has an anatomical program within what's called the gross anatomy facility, and essentially wanted to know, could we establish this type of program here? But we didn't know what the spread of the DNA quantity and quality and recoverability is going to be out of the remains we had within the facility. So this was essentially a survey to see what we had and what we could do. So the GAF within the biomedical sciences at the University of Queensland is the largest anatomical, prosected and skeletal teaching collection within the state of Queensland. And we receive approximately 100 bodies per year donated to the program. And these bodies can be, and samples can be maintained for up to 10 or 20 years before being returned or disposed of. And so these specimens can be anything from whole bodies through to prosected limbs and torsos, etc., various body parts. We have isolated organs that can be preserved within pots, and of course skeletal remains and collections. But these specimens are all embalmed and protected and preserved with embalming solutions, which could either be commercial or in-house versions. So there's a lot of variation. But embalming, of course, is there to preserve the human tissues. It's used within funeral homes, within these types of anatomical collections and pathology to preserve the tissues, but it also greatly degrades and damages the DNA. So how these embalming works usually falls within two general methods. Either the whole body or the organ is embalmed is immersed in the embalming solution, or the solution is flushed through the circulatory system for diffusion. And the most common agent used is a formalin-based preservative, and of course, as we know, that creates extreme DNA damage and degradation, particularly with cross-linkage and fragmentation. As most of us would be aware, that AFDL have also encountered this problem with a lot of their remains that they've recovered their skeletons and bones from the punch bowl, where these bones we know have been immersed in these really, really aggressive formalin-based embalming solutions and powders. So this project really started by a survey of what was in our GAF and what is the likelihood of being able to recover any sort of amplifiable DNA. We sampled hundreds of tissues across the body, but because this is a bone talk, I wanted to focus more on those. So out of all of those, we had 72 bone samples that were recovered, and these range from bodies that were embalmed for from anywhere from 1 week through to about 13 years. And we employed the same DNA extraction method as what I've previously described in this talk. So using the bone chipping method with the BTA kit for bone extraction, for DNA extraction. We recovered a range of DNA concentrations as we would expect, but the majority of the samples, we actually recovered more than 100 picograms per microliter to be able to amplify for STR analysis. We had very few samples with very small amounts of DNA. However, the DNA degradation index, or the DI, was ranged quite substantially, from anything from very mild to moderate degradation to extremely high degradation. And some of these samples were so degraded we couldn't even get a DI value for. However, we did not detect any PCR inhibition at all, so we were very confident that the extraction process was very efficient. So in terms of the results from the bones themselves, as you can see, around about 3/4 of the samples we recovered more than 90% alleles in our STR profiles, and only a few of the samples were generated less than 30% allele recovery. And these samples were the samples that were much older or been embalmed for much longer, between 4 and 13 years. But 65 out of those samples were able to be positively identified back to the donor. So out of interest though, like all the tissues as a whole, what we did find was that when we looked at the quality of our STR profiles, these did generally decrease over time, but it was actually more dependent on the tissue used, whether it was skin or muscle or lung or liver, which obviously I don't have time to talk about, but it was extremely interesting. Another little interesting thing we found was that we recovered a lot more higher quality DNA that led to more complete profiles when we recovered the tissues from the lower limb versus the torso or upper limb part of the body. So we thought that was interesting, that needed to be, that warrants further investigation. So really, to summarise this talk, we found that the PrepFiler BTA kit has been extremely effective on a very wide range of skeletal material that have been exposed to lots of challenging environmental insults, and we were able to do this with and without bone powdering. So we found that the BTA kit is extremely aggressive in terms of its lysis and effective in recovering DNA from these bones without the need to powder. We've also demonstrated that increasing the PCR cycle for these challenging bones does improve the recoverability of alleles without introducing too many more artifacts. We also found that the PrepFiler BTA forensic kit was very effective in being able to use for recovering DNA from these embalmed samples within an anatomy facility. For samples that were embalmed for up to a year, we generated very successful STR results. After that, the samples we would assume would need a little bit more work to be able to get a definitive identification, most likely down the route of SNP typing and used via MPS. But it does show potential for being able to create a DNA registry to establish provenance of these types of samples within body donor programs. So with that, I'd like to acknowledge and thank Thermo Fisher, of course, and in particular Angie, Sheree, and Lucy for their support and over the years, and then also the Department of Forensic Science and staffs at Sam Houston State, and all, of course, the donors and their families that made this work possible. So with that, I'm happy to take some questions. But other than that, I will hand over to Rachel, who will be telling you some really interesting information about using rapid DNA technology for bone samples. Thank you.
Hello, thank you for joining us today, and thank you for that introduction. My name is Rachel Oefelein, and I'm the Director of Research and Innovation at DNA Labs International. And I'm going to be talking today about the Rapid Hit ID system and our evaluation for processing of skeletal remains. DNA Labs International is located in Deerfield Beach in sunny South Florida, And we're celebrating over 15 years now, partnering with law enforcement across the United States as well as Caribbean nations. Our initial testing and evaluation began in November of 2018. And then in May of 2019, we actually had the Rapid Hit ID system installed. We initially had a different instrument, so the actual Rapid Hit ID system was installed in May of 2019. We're currently finalizing our validation. We had added on a couple additional procedures, so that involves some of our delays in getting signed off, but we're so excited now to be offering the Rapid Hit ID system in our suite of offerings at DNA Labs International. So what is rapid DNA? The FBI defines rapid DNA as the fully automated, hands-free process of developing a DNA profile from a reference sample buccal swab without human intervention. We develop a DNA profile in under 2 hours from a body fluid sample as an investigative aid. Most bone extractions can take anywhere from 12 to 72 hours. I have noted here that this is laboratory dependent, but it's not actually just laboratory dependent because it's also bone dependent. So when we get really challenging bone samples, sometimes, for example, with our demineralization method, after that initial incubation, you might not have full demineralization. So we can respike that sample and give an additional incubation period. In addition to that, a lot of bones yield very small amounts of DNA. So one extraction might not even be enough. You might have to do 2, 3, 4 extractions. We have one genealogy case in particular where we had to do 8 extractions to get enough DNA to go forward with genealogy. Bone extractions are incredibly labor intensive and they require special equipment and training for handling them. It also requires a designated screening area. You wouldn't want to be screening bones right next to where you have high quality samples. At our laboratory, our high quality and low quality bones are separated as well so that they're not being done in the same area. So that goes for all the equipment that's used for screening them too. So what technique are we actually using? I've included a few pictures here. This is one of my favorite things to try to explain to examiners when I say, I want a cross section of bone. They're like, well, what the heck does that mean? I always try to say, I think a lot of forensic scientists do this where we compare everything to food. But I always try to say we want it to look like a short piece of celery. So you want just that cross section where you have the anterior exposed as well. And we do a lot of times get full sets of remains on occasion or full femur bones. But really it saves everyone a lot of time, effort, and money to just submit a cross section. So I would highly recommend if your law enforcement or medical examiner system has the ability to cut that cross section for you to request it to be submitted in that way. So we usually take about a 2 to 3 inch section. And if any tissue or debris is present on the bone, a simple initial cleaning is required. So you can either scrape that bone or again, use a cutting wheel to try to get that removed. However, if the tissue is pink and healthy looking, abort mission, don't go forward with the bone extraction. Healthy pink tissue is much easier to extract than a bone. So I would recommend at that point just removing the tissue and taking that forward. The bone must be sanded using a Dremel tool to remove potential contaminants. A lot of times we get remains submitted that were discovered by civilians. It's maybe gone through the hands of multiple medical examiners. Sometimes with cold cases from the 60s and 70s, people had handled it with their bare hands. So we want to get any of that potential extraneous DNA off the surface of the bone. In addition to that, we also want to get anything off the surface of the bone that could be inhibiting our reactions. So, for example, chemicals that might have been leached into the bone from the soils, or anything that it could have been exposed to over time. Sometimes we get remains that were prepared for embalming, so we're going to want to get any of those materials off. Really, by the end of it, you want it to look like a perfect piece of porcelain china, is how I always describe it. And at that point, you're going to have to go through multiple washes. So we'll do water and ethanol washes. And you're going to want that to fully dry. So if you are going forward for a demineralization extraction, we're going to do a mixer mill powdering method. And if you have any moisture remaining, really, you're just going to end up with a paste. So we want that bone completely dry before it goes forward. So the bone fragments are broken up, and we do that in mortar and pestle and ground into smaller pieces or pulverized into powder. Powdering the bone exposes a greater surface area for the extraction reagents to reach, resulting in a higher extraction yield. Cleaning materials, so we want to make sure all the materials in the hood that we're using is completely free of any remaining bone powder from previous samples. Bone powder gets into everything. It's very easy to have bone powder left behind, so you want to make sure that you're doing multiple cleaning steps in order to ensure that you don't have cross-contamination between samples. So the types of things we're using for cleaning are bleach, soap, detergents, ethanol, cleaning reagents, as well as UV lighting. And this process is performed inside a specialized hood with filtration capabilities. So any bone powder that's going into the air is going to get through that filtration system so that we're not having a deposit of bone powder across the hood. So going into a little bit of our validation study, what we looked at initially for our sensitivity and stochastic. I say stochastic too because really with the rapid system, we treated it like a new PCR kit. So we aren't actually analyzing on the actual instrument. We're using gene marker on computer. So we take the data from the rapid and then analyze that separately off instrument. We did that for a couple of reasons. One, we are not an NDIS participating laboratory. So although we work with a lot of NDIS participating laboratories, we do not have direct upload to CODIS. So really that feature doesn't serve a function for us. And in addition to that, we wanted the ability to be able to edit our samples and have a higher pass rate. So by analyzing off instrument, we're able to account for dropout, peaks that are below stochastic thresholds, and be able to make better use of that data. So really we treat it like a brand new kit. We have our own analytical thresholds, our own stutter filters, our own stochastic threshold. And so moving forward into what we did with the bones is we obtained a high quality bone sample from a known source. We ground the bone sample into a small chunk consistency. For those of you that are wondering what the heck is a small chunk consistency, don't worry. I've got a slide for you coming up that I'm going to explain. And we prepared 2 sets of bone samples weighing approximately 10, 50, and 100 milligrams. I say approximate, and you can see that they're pretty close, but when you're dealing with bone chunks, it's virtually impossible to get it to weigh exactly the same. So there's slight variation there, but they're pretty close. And we ran those samples through Rapid using Intel cartridges, not the ACE cartridges. So the ACE cartridges we're using pretty much specifically for buccal swabs. You can also do body fluid samples for those, but really the ACE is mostly going to be for buccals. The Intel has a higher cycle number and a slight variation in the buffer for it, so you're getting higher RFUs from that. So when you're dealing with bone samples, which can be tricky, obviously we want the most sensitive option. So we processed the raw data and we looked at average heterozygous peak heights as well as sister allele balances. And as I mentioned, we analyzed the gene marker off instrument. We did actually look at it on instrument as well too and compared how our 2 methods differed. So remember, I mentioned that small chunk consistency. What does it mean? If the consistency is too fine, it will clog the system. So I always say, think of a sea salt grinder, like that fancy pink Himalayan salt. That's the consistency that you want for your bones to make sure that you're not going to clog the system. So for regular full demineralization protocols, we're going to run our samples through the mixer mill and get that super fine powder. That is not how we want it for the rapid system. So how is the data? Here we have high quality bones resulting in full DNA profiles from all amounts tested. So again, that was 10 milligrams, 50 milligrams, and 100 milligrams. By high quality, I'd say this is probably the most common question I get from people when I talk about our rapid skeletal remains protocol. I would classify high quality as a subjective term, but really what we're looking at is samples from remains that were found within 12 months of the time of the individual becoming deceased. And we want it to be in good environmental conditions. So preferably in a cool environment in the morgue, but if they are outside, we want nothing with high heat, fires, bogs, acidic soil, things like that. That are going to degrade those remains. And I would also add in the caveat of no chemical treatment. So when we have remains that have been treated with acid and oil drums, things like that, that is not going to be a good sample for the rapid hit ID system. Here we have the first bone from 10 milligrams from set A. As you can see, we have a beautiful profile here. It was about 9.9 milligrams, which is a really, really small amount of bone. And I can see here the average peak heights for blue, green, yellow, red, purple, and overall. Here we have set B. So this is a similar size sample, but from the second set. And you can see we have very comparable results. And again, a full, beautiful profile. Going up to 50 milligrams, set A. You can see here we have a slight increase now in the peak heights. And similar again for set B. Even though this was 47.3 milligrams, so slightly less input, but you're really not seeing that big of a difference. When we get up to 100 milligrams, that's where things get a little interesting. So you can see all those E's and X's. E's are edits. X's are things where we've had to delete peaks. And you can see there's a little bit of noise on that baseline. So I'm going to give you a better zoomed in peak or picture as well of that, but it's increased artifactual peaks and edits. So basically we were seeing a really high amount of artifacts when we got up to 100 milligrams. So at our laboratory, we recommend sticking in that 10 to 50 range for high quality remains. Here's a zoom in on the yellow dye channel. So you can see all these extra little peaks here. Some of them aren't sizing. So you can see there's a lot of OBs, but some of these are actually falling into bins. So you would need to be cautious that this wouldn't register as a mixture. So again, this is another advantage of analyzing off the instrument is that you have additional options. Sorry, excuse me. A lot of allergies down here in Florida. We have endless summer. So here we have bone 1 at 100 milligrams, and this is for set A. You can see in the red dye channel too, we have this split peak here. So set B for 100 milligrams was pretty similar. We have those increased artifactual peaks and edits. Here zoomed in, you can see that as well. So the good news about this is we can identify these and make record of them. So if you do have these artifacts pulling up in your profiles, we have the ability to edit these. But again, the ideal is to just reduce your amount of input and then not have to deal with these artifacts at all. And here we are on the red dye channel. So you can see it's not limited to a single dye channel. We across the board are having quite a bit of edits and artifacts. I will give the disclaimer from those two that this was before we had set our AT. So our analytical threshold is actually a little bit higher. So a lot of those might not have come in, but for the really tall peaks where we're seeing that bifurcation, those are absolutely still going to fall in at that 100 milligrams. Here we have our average peak heights plotted against the bone amount. So you can see as expected, the higher the input of your bone amount, the higher of your RFUs. And you can see pretty comparable between the two. Set 2 had maybe a little bit less, was more around like 2,500 RFUs, whereas set 1 was around 3,000. And that one is almost 3 milligrams left, but I think it's like actually just coincidence because they're pretty comparable. So I don't think those 3 milligrams really made or break it for those RFUs. Just another way to look at the data is this is average peak height by locus versus bone input. Just going through, you can see the 100 milligrams versus the 47.3 and the 93. So overall peak height ratio versus bone amount. So you can see actually across the board, regardless of our input, we have really great peak height ratios. This is what we would expect to see from any well-performing kit. So we're ranging from about 76% to 83%, which, as you know, anything over 70% is great. So this is what we want to see. Here we have dye channel peak height ratio versus bone input. Again, really well balanced regardless of input. We're having great peak height ratios regardless of dye channel as well. And here we have the red and purple. So how does this compare to our current methods? So we have our original demineralization bone extraction method, which is an overnight incubation, the hands-on time, so taking out the bone saws, taking out the cutting wheels, Dremel for sanding off those bones and getting that clean surface, all those washes. It's about 3 hours of hands-on time. I would say that's conservative. If you're brand new, it might be more 4 or 5 hours, but additional processing time to obtain that fine powder. So we're adding that mixer mill step now at this point. And the other thing to it's important to mention here is that we have multiple tubes required. So we're doing multiple phenol washes, and because you have multiple tube transfers, you're exposing yourself for the potential for a contamination event. So we want to limit our tube transfers as much as possible. And we also brought online a large volume extraction method. That involves a butanol wash as well. And instead of being performed in microcons, we're now in ultra 4s. And this whole process was actually brought online specifically for genealogy. We were finding for our investigative genealogy cases that sometimes we were having to do 2, 3, maybe even 4 extractions to get enough DNA to go forward with genealogy. So I don't know if you can see in the tiny camera, but DNA for a CODIS STR profile, you need this much, whereas genealogy, you need like this much. It's a lot more DNA. So we wanted to bring on a method where we could get higher return DNA from our extraction yields and hopefully limit having to do multiple extractions. So here's our current bone extraction method against the large volume extraction method. And you can see pretty much across the board here, not even pretty much, it's every single sample, we had an increased yield. And what's interesting here is that these are actually really similar inputs. So for example, if you look at the first one, we have 170 milligrams versus 160. So we've actually put in a little bit less input for bone powder here, and yet we're having a higher yield return. So this is ideal for our genealogy cases. Our original bone method, we actually only use typically for teeth at this point. So here we have our current bone extraction method versus the large volume protocol and the rapid HUT. So this is looking at our inputs versus the amount of nanograms of DNA that we obtain. So you can see that rapid HUT actually holds up pretty well when it comes to the high quality samples. So what about quality? None of this means anything if we don't have high quality, right? So we have all samples, the correct profile was obtained. We had multiple replicates of the same bone source producing consistent profiles, and we had no signs of contamination. So overall, a quality win when it comes to the high quality remains. We're getting high quality profiles. We want to know, though, what happened to that bone after the test. So the bone can be removed from the cartridge after testing. If you haven't actually seen the cartridge yet, it's about this big, and it has an opening where the sample actually goes. So those bone chunks are not being demineralized. We're not, turning to a liquefaction of the sample. We still have those bone chunks there afterwards. We wanted to know if you could retest them. So if you had a limited bone sample, for example, and you put that in and say your run failed, would you be able to put that into a new cartridge and then rerun the sample? And we found that actually you can. So this is multiple tests of the same bone sample. I will say that we actually did 3rd and 4th rounds of this too. I don't think I have the data on this presentation, but you can see that your overall RFUs decrease with each test. However, we're still getting a full profile. So as long as you get a full profile, it's a win at the end of the day. We're not typically going to be rerunning these samples all the time anyways, but it's nice to know that we have that option in the event that we needed to reanalyze that sample. It also means that you could technically retain that sample for all of time and keep it so you're not having that deleterious effect. Multiple testing the same bone sample through the rapid HIT IC system using the Intel cartridges. So here we just have those average peak heights per locus. And this is a 10 milligram high quality bone sample, just to put things into perspective. You'll notice at Y-indel and DYS 391, we have 0 RFUs. If you're wondering why there's those dips in the peaks, it is because this is a female, so we don't expect any RFUs at the YSTR locations. So what other options could we look at for bones? We wanted to see, we spent a lot of time actually trying to see if we could get samples that were low quality or what we would say is medium quality bone samples. So maybe higher in age, like 10 to 15 years, but was in really good quality conditions to see if we could get those to work. So we tried just running the bone extract through to see what kind of DNA profiles we would get from that. We also looked at partially digesting. So doing a round of demineralization buffer and an incubation of those bone chunks, and then loading it into the rapid cartridge to see The advantage there would be you would skip all the phenol washes. Phenol is a nasty chemical, so as much as we can limit that in our laboratory would be great. So we wanted to try that out. Bone extract is actually fine. The partially digested buffer is fine for high quality. However, for those medium and low quality samples, we're still not obtaining a DNA profile. So as mentioned, we looked at those low quality bones. We evaluated bone chunks versus partially digested and bone extract. And although you can get the profiles from the bone extract, at that point, there's not that much of a point in going that route. All it does is save you a little bit of time off of loading on the actual CE instrument. So I would not recommend this for low quality or medium quality bones. I would stick to your original methods. Where you're really going to save time here and get good results is those high quality samples. So I want to throw in a mention here for the application note that Thermo has released for bone sample processing on the Rapid Hit ID system with Rapid Intel cartridges. DNA Labs International, in addition to a couple other laboratories as well, participated in sharing their research and their methods for how they process bones using the Rapid Hit ID system. So I would say if your laboratory is evaluating whether or not to bring this online, this would be a great resource to see the different options that other laboratories are using. So what else can we do for uses for rapid testing of bones? You might be wondering, who cares if you save, a day or two processing? What would require you wanting to have these quick results? So reassociation is a big one for us. So small plane crashes, dismemberment cases where we're trying to reassociate all the fragments of remains back to one individual. We're able to rapidly do that. If you think of cases, especially with highly fragmented remains, where you might have an individual comprising 50 different evidence submissions, this would be a great option. Lot less hands-on time and makes your people doing manual extractions probably really happy with you. It's also great in disaster human identification, where you're trying to quickly get answers for the families that have lost loved ones. And then rush cases. So we still have buccal swabs processed in our traditional methods in our laboratory. But if you have an individual that is a case where they need very quick results, this is a great option where you can get your full DNA profile in 90 minutes. So what do we do then if it's disaster human identification? We will do parent-child, siblings, half-sibling relationships so that we can compare to that unknown profile and identify through kinship. What else can you do? So if you don't want to just only do bones on your Rapid Hit ID system, it's also great for muscles, organs. I would say tread carefully with a spleen or a brain sample because those will clog the system as well. So really with the heart and liver, what we were doing is just kind of mincing the sample and taking that forward. But I would say samples like spleen or brain that kind of, for lack of a better term, go when they go into the cartridge, I would recommend swabbing the tissue or the organ opposed to actually putting it into the cartridge. Teeth work excellent. We love teeth. And then as I mentioned, those rush cases for buccal swabs or body fluids. So what else is new? I mentioned a little bit on our large scale extraction method. So these are for very degraded bones, and it's a large scale format to produce higher yields of DNA. So larger quantities of DNA is what we need for genealogy testing. It's also great when you want samples to go more than one direction. So sometimes we want that SNP profile for genealogy, but we also need an STR profile to be submitted for CODIS upload potentially with a vendor or from the vendor laboratory going to the ENDIS participating laboratory. And we like to save extract if we can for future testing or defense testing. So this is a great option where you're getting high yields of DNA to meet all the needs of testing for your case. I just want to touch on our #DNA opt-in campaign. DNA Labs International has launched this campaign in the past year to try to encourage people to opt in their profiles for law enforcement on GEDmatch and Family Tree DNA. So anyone and everyone can help solve crime. You may even know someone who has been the victim of a violent crime or had a loved one who has gone missing. These photos are the faces of the many victims of unsolved violent homicides. It is our mission to find justice for them. Opting in your DNA on GEDmatch may help investigators to find a killer a rapist or identify the thousands of unidentified remains in morgues around the country. It really is truly just so sad, especially if you look at the NCMEC map and see how many unidentified remains of children in particular, but adults as well, it's in the thousands. So as forensic scientists, it'd be great if we can spread the word that Optan for Law Enforcement can help give answers to some of these cold cases. Here I have some references for you. So I mentioned that application note released by Thermo. There's a link to this here. Also, Naming the Dead, Confronting the Realities of Rapid Identification of Degraded Skeletal Remains by Suni Edson. And then a couple other resources just that I've mentioned here as well for you to refer to. I'm happy to always answer any questions. So as well, if you want, just give me an email or feel free to call as well. And we're always happy to share information. I want to give a special thanks to Forensic Magazine, Thermo Fisher as well, for providing us this opportunity to share this information, and my team at DNA Labs International. Without you all, none of this would be possible. So thank you so much. And thank you for the entire audience for your attention today.
Thank you, Sheree and Rachel, for that great information and insight. Audience, it is almost time for the Q&A portion of our webinar. If you have not already, please take a minute to ask our presenters a question using the Q&A dialog box on your screen. Unfortunately, Sheree won't be able to join us for the Q&A due to unforeseen circumstances, but we've still got Rachel, so don't be shy with the questions for her. Additionally, if you do have a question for Sheree, please do send it regardless, and we will make sure she gets it and provides an answer for you. While you think about your questions, for our presenters, we're going to throw up 3 polling questions for you very quickly. Our first question is, how many bone samples does your laboratory process per year? None, 1 to 50, 51 to 100, 101 to 500, or over 500? Take a minute to go ahead and let us know about your laboratory. All right, I'll gather these results right here. All right, it looks like most of you guys are doing 1 to 50. All right, let's move on to our next one. Audience, how prepared is your agency to handle disaster victim ID situations? Your options are not prepared at all, somewhat prepared but need improvement, fully prepared, ready for anything. Go ahead and take a minute to tell us how your agency handles these DVI situations. All right, let's see what you said. That's great. It looks like most of you are, the majority of you, are prepared but need a little improvement, while some of you, a good portion of you, are fully prepared and ready for anything. Always good in today's world. All right, last question before we get Rachel up here. Our last question is, would you like to receive more information on today's webinar topics? Yes, please contact me for a demo on the Rapid Hit ID system. Yes, please send me pricing info and technical specs on PrepFiller BTA and Automate Express Forensic DNA Extraction System. Yes, please send me pricing info and technical specs on the Rapid Hit ID system. Yes, I would like to discuss further with a live person. Or no, not at this time. Go ahead and take a minute, and then we will gather these poll results and let you guys see what you said. Thanks so much. That's great insight from you guys. So we appreciate you taking the time to do these polling questions. And now we are going to get to the extra fun part of the Q&A section. So, Rachel, we have a bunch of questions for you coming in. Our first question for you is, what is the oldest bone you have obtained a profile from?
I'd say the oldest bone that I've obtained a DNA profile from was from the 1800s. So really, it depends on the bone condition, because then we've also had bones that were from the last decade where you struggle to get a profile sometimes. So it really has to do with the environment that the bone has been in and how the evidence has been preserved.
Wow, that's incredibly cool and fantastic technology on your part. That's great. Okay, so do you have any more tips for our lab researchers for evaluating bone quality prior to processing if age is unknown?
For us, it's really about the visual evaluation. So a lot of times if we have bones coming in, we will ask for them to send pictures of the remains so that we can try to select from the photos so that we're not receiving full skeletons at the laboratory all the time. Our evidence manager would kill me if we did that. So usually we ask for photographs, but then a lot of times you really have to physically see it in person. So we're looking for discoloration, how thick and how dense the bone is, if there's excess spongy bone. Those are things that are red flags for quality. When we're looking at teeth, we're trying to avoid any teeth that have cavities in them as well. So those can all be signs that you might have a little bit of difficulty with the bone.
Okay, gotcha. So how do you powder the samples with the Dremel without spreading the DNA particles throughout the entire laboratory?
So this is a question that came in, I believe, for Sheree, and I would feel free to recommend following up with her as well. But we also use Dremels at our laboratory, so I felt like I could probably help out with that a little bit. We use specialized hoods with filtration devices that are vented and have airflow. So you can literally, as you're sanding, see the bone powder lifting up and for anything that comes loose, but the rest that we have down at our working areas collected into weigh boats when we're doing that.
Okay, gotcha. Well, while we're talking about sanding, once a bone sample is cleaned via sanding or another method, do you believe it is necessary to use bleach rather than a more gentle detergent wash before powdering or beginning the DNA extraction process?
We don't use bleach directly on the bones at our laboratory, so we do bleach all the tools that we use, and the surfaces that within that hood have to be cleaned very, very carefully in between samples. But on the actual bone itself, we use ethanol and water washes. I'm always cautious of ever applying bleach to bones because I just worry about it affecting the quality of the sample. I know a lot of laboratories do. But ours, after sanding, I don't see any need of doing any washes outside of ethanol and water.
Okay. Then, after all this, how do you know when a bone sample is completely dry?
So part of it is just actually physically looking at it. So we have them drying in a vented hood, and they're in a weigh boat. So our last wash is an ethanol wash, which really helps it dry a lot quicker. But you'll see if you go in and flip that fragment that there will still be liquid remaining on your weigh boat. So it's usually pretty obvious, but we give it a good half hour and make sure that it's completely dry. And at that point too, we're dealing with a very small bone fragment. So it's not like you're trying to dry out an entire femur bone. We just have a small fragment that's then perfectly clean with a smooth surface at that point.
Is it possible to know how old the bones you're treating are?
So a lot of times with the bones, you have to go off of the information that's been provided to you by the investigator, but you can also tell visually. I will say a caveat to that is that a lot of times bone samples could be a really fresh sample, but maybe it's been exposed to very harsh conditions, so it can give the appearance of being older. When in doubt, I would just say, it depends on how much sample you have, but if you're concerned about your quality, I maybe wouldn't go straight to rapid at that point. Unless you have plenty of sample to work with, and you could always try rapid and then move on to a demineralization, followed by an organic maybe to clean that up if need be.
Okay. Now, how do you prepare teeth for analysis?
For teeth, if it's going the rapid, we'll simply just crush the tooth and remove any enamel, and then the remainder of the tooth is going to go into that rapid cartridge. If it's not going for rapid and we're going to go demineralization, then we'll still crush it and remove the enamel, but then it's going to go through the mixer mill and get powdered to that fine powder prior to extraction.
Okay. We have a user over here that's wondering what your experience has been, Rachel, with waterlogged bone samples. He's had some trouble using various extraction methods or commercial chemistries over the years. What do you use for waterlogged bone samples?
Our waterlogged bone samples, it would depend on how long it's been in the water. We get a lot of small plane crashes and things like that where maybe it's only been in the sea for up to a few days. I find that they actually work great. We're lucky down in South Florida here that we have high saltwater content and things like that. So I find that it actually does really great at preserving the remains. Those are samples that we would even consider going forward with rapid on. Other samples, though, say it's been in water for years and years and years. I've actually also had really good luck with those as well, as long as it's salt water. Where things have been a little trickier is if it's in, like, say, a really acidic bog or something like that, where it's going to be a harsher conditions. In those cases, I would not attempt the rapid at all, and I would go straight forward with demineralization and organic.
Okay. Now you mentioned, that salt water in Florida is great for the bones. What about temperature? Does temperature affect the quality of DNA extracted from bone?
Yes, anytime you have really, really high temperatures, so like explosions where there was maybe a sustained fire with high heat for a long period of time, that's going to affect the quality, as well as sometimes when we have samples maybe from up north that have been exposed to multiple freeze thaws, so you have the remains being frozen, and then come spring, they thaw out again, and then go through that cycle again for decades. That can also have a negative effect on the quality of the sample.
Okay. And now, have you worked with and evaluated samples exposed to extreme conditions such as disaster victims or those recovered from seawater, like you mentioned?
Yes, I'd say a big portion of the types of remain identifications we do are from, fragmented remains from, say, like a plane crash or something like that. So this would be a great option for processing those. And it really depends, again, with anything involving explosions or anything like that, how high the temperature was, if it was a sustained fire for an extended period of time. With that said, though, we've gotten great results on samples that have been in car fires for an extended period of time, too. So sometimes it is just luck of the draw.
Okay. What about cremated remains? Are you able to get a DNA profile from that?
Cremated remains are very challenging. A lot of times, too, that would depend on the actual individual that was cremated. So if you have someone with, say, a much higher fat content, it's very unlikely that you're going to have anything of substance left in the cremated remains a lot of times. Whereas, say, a very thin individual, you may still have bone fragments remaining. I would say it's an incredibly challenging sample, but if there are any fragments remaining, that's definitely always something that you could look at. I would not recommend that for rapid. Would be something that you would want to go a more sensitive route, like a demineralization, to try to maximize any DNA that can be obtained.
Right, of course. Okay. Now, how many swabs do you need to take from the organs when testing?
We would just do a single swab going into the cartridge. So you can always, it depends on how much large your piece of organ or tissue is. But you could just press into that swab and kind of roll it is how we do it to try to absorb some of the blood and the fluid from that tissue.
Okay, wow. All right, now what is your recommended approach to IDing a severe burn victim for whom there is no large skeletal remains like a femur, tibia, rib, or so?
If there is no large skeletal remains?
Yes.
So a lot of times if it is burn victim first, we will attempt for tissue. So I would always ask for a piece of the psoas muscle, which is kind of protected in that hip pocket. So a lot of times, even if there's no surface tissue, you might be able to still get tissue from within that hip pocket. After that, really it's just what's available. I feel like a lot of times teeth can persist in fire situations, so we'll always ask for molars that are cavity-free first. And then after that, we would ask for a femur or any available long bones.
Gotcha. Okay. Last question, as we're running out of time. Did you try to use freezer mill for powder?
We did not. We used to use blender cups, and then we moved on to mixer mill.
Gotcha. Okay. All right, audience. That about wraps up all the time we have for Q&A today. So thank you for your participation throughout this webinar and this series. I'd also like to take a moment to thank Thermo Fisher Scientific for sponsoring this webinar, and a big thank you to our speakers, Sheree and Rachel, and especially for this live Q&A. This was great. We hope that we were able to answer all of your questions. In about 24 hours, this webinar will be available on demand if you would like to watch it again or share it with friends and colleagues. Additionally, you will receive an email with information on how to obtain CE credit documentation for your participation today. The sixth and final webinar in the Future Trends in Forensic DNA Technology series will be held October 15th at 8 a.m. Pacific, 11 a.m. Eastern. From this window, you can scroll down in the overview section to register for the sixth webinar now. If not, you could also register later for DNA Hit of the Year 2020, DNA Database Programs Help Solve More Crime via the Forensic website, www.forensicmag.com. You can also view all the other webinars in the series on demand. Thank you so much for joining us today, and we hope you have a wonderful rest of your day.